In this short video, I'm going to introduce you to one important topic in hydrology, that is overland flow generation. When we are talking about overland flow generation, we need to discuss two very important mechanisms, infiltration excess and saturation excess. The amount of surface runoff that is generated using the infiltration excess mechanism is also known as Hortonian runoff, named after Robert E. Horton, and the amount of surface runoff from saturation excess mechanism is called Hewlettian runoff, named after John D. Hewlett. All right, I'm going to give you a very quick and small definition of these two mechanisms and then show you an experiment. In infiltration excess mechanisms, overland flow begins when rainfall intensity is greater than infiltration capacity. We're going to come back to this definition, but let me give you another short definition of saturation excess. So whenever you're using saturation excess mechanisms, you're assuming that overland flow begins when top layer of the soil is saturated. All right. I have a sponge over here and also a bottle of water, and I'm going to show you these two mechanisms using a very simple experiment. This sponge is a porous medium. It has a lot of pores. Soil also has a lot of pores, right? So this sponge is a good representative of the soil. Also, I have a bottle of water over here. I'm going to apply water on top of this sponge, on top of the soil, and see what happens. Right now, the sponge is dry. So first, I'm going to apply just a little bit of water on top of the sponge and observe what happens. This is my sponge. I am applying just a little bit of water on top of the sponge. As you can see, the water that I'm applying on top of the sponge is absorbed by the sponge, and the rate of application is very slow, right? Now, what happens if I increase the rate of application? So I apply a lot of water on top of this sponge. Let's observe together. I am applying a lot of water on top of the sponge. As you can see and hear, when I'm applying a lot of water on top of the sponge, some of this water is running off the surface of the sponge to the pond that I have created over here. Now, let's think about it. When rainfall intensity is larger than infiltration capacity, you will have overland flow. Now, when the rate of application of water on top of the sponge was less than infiltration capacity, no overland flow was generated. But when the rate of application of water on top of the sponge was higher than infiltration capacity, then water started to run off the surface of the sponge. This is how we can have a good physical understanding of infiltration excess mechanism. How about saturation excess? Can we use the sponge and water to understand saturation, physical meaning of saturation excess? Yes. So right now, this sponge is not fully saturated. I'm going to soak it into this water to make sure all these pores, or at least most of them, are filled with water. Get rid of the excess water. All right, so I'm going to assume that this sponge right now is fully saturated. What I'm going to do, I'm going to apply just a little bit of water on top of the sponge and see what happens. So I'm going to apply a little bit of water. As you can see and hear, I'm just applying a little bit of water on top of the sponge, but because all the pores in this sponge are they full with water and the sponge is saturated, the water is running off the surface of the sponge into the pond that I have over here. So this is basically what saturation excess tells you. Overland flow begins when top layer of the soil, our sponge, is saturated. This experiment helps you to understand the physical meaning of these two mechanisms. But now you have a question in mind. Which mechanism should I use to simulate overland flow, to simulate surface runoff? The answer to that question is that in reality, when you have a watershed, both of these mechanisms occur together in a watershed. So if you have an area that is semi-arid or arid, infiltration excess mechanism is dominant. But if you have another area in the same watershed in which water table is closer to the surface ground, then saturation excess is the dominant mechanism in that area.